Okay, we are almost ready to roll. Welcome, everybody. Okay, let's get started. Welcome, everybody, to our 11th lecture series for the NixOS Summer of Nix. So this is our 11th lecture, and it's maybe our last. We might have an extra one or two. But this has been a really great series. I've had a lot of fun organizing this. I wanted to thank Brian for moderating all the lectures up to now. He's taking a very well-deserved week off. This week is also the last week for Summer of Nix. So everybody's been working hard on their projects. I hope all the participants enjoyed it, learned a lot. Please feel free to give us as much feedback and as much kind of things we can do to improve this program. This is only our second edition doing it. And yeah, we'll be kind of gathering the outcome and the feedback and all the work that's been done around all the packages over the last handful of weeks. So as usual, I want to thank a few people. Thanks to NLnet and the European Commission for helping fund this and giving us all the packages to work on and giving us just opportunity to kind of contribute to this amazing project. The NixOS Foundation has helped immensely in funding and organizational support and just direction for making this program a reality. And finally, thank you to Tweag, who has helped us just make this program a real thing with people like Brian and Matthias, and just a huge support for the Nix community in general. Another announcement is NixCon is happening. It will be October 20th and 21st with a hackathon on the 22nd, I believe, in Paris. So check out the announcement. That's linked right here. Hope to see you there. It'll be always good to see people in person, and we'll have a pretty cool list of lectures announced shortly. Moving on to today's lecture, I'm particularly excited for this one. So today we have Connor Brewster, who's a software engineer at Replit, a small company you may have heard about, that has been using Nix to deliver a product that is really unique. And they've been shipping like there's no tomorrow, and this kind of delivering this product that no one really thought would be able to exist. And Nix is kind of an important part of how they made that happen. We talk a lot about Nix adoption and how do we get Nix in the hands of people. And Replit has millions of users that are using Nix, and it's not obscured from them, and they can see that they're using Nix, and they're getting introduced to it. So I think we should really pay attention to this adoption story with Replit, because I think it's an important vector for Nix adoption in general. Feel free to drop questions during the lecture. I'll be tracking on the various channels we got going. But without further ado, I will add Connor to this stream. Hey, Connor.
Hello.
All right, you sound good.
Awesome.
All right, I can see your slides. I'll let you take it from here.
All right, thanks for the great introduction. So yeah, as Julian said, I'm Connor Brewster. I'm a platform engineer at Replit. And today I just wanted to share kind of the story to how Replit came across Nix and how we've integrated it into the platform. So if you haven't heard of Replit, just a brief overview. We're an in-browser collaborative coding environment. You can use any language, framework, library. You can build whatever you want. You can write bots. You can host web servers. Kind of do whatever you want. Our goal is to not get in the way or to pick certain tools that you should use. You should be able to write in any language that you want. And here's kind of like an example of what the workspace looks like today. So I kind of want to go back to like the origins, how Replit started. So this is historical. I was not affiliated with Replit at the time. But originally, it was our founder, Amjad's side project. And the basic idea was that anybody should be able to start learning how to program in a new browser tab. Because before, it was just like way too much setup you'd have to do locally. It was just a painful experience to install all the tools before you could even start writing your first line of code. So the first approach at this was, running various languages client side. Started out with just JavaScript, and then eventually they started compiling like Python and Ruby to Emscripten. I think this is like pre-WebAssembly days. And you could just, write some Ruby code locally. Here's like a picture of what that looked like. And this was perfect for a side project. You run everything client side, so you don't have to pay for anything to host this service other than just like static hosting. But you quickly run into limitations, at least for your users. You have limited browser APIs, especially, like 10 years ago, there's a lot less you could do with the browser APIs. You don't have like true access to the network and the file system. You can kind of emulate some of this, but it's just not the same as like running on an actual like Linux machine. And then there's also just a lot of work that goes into making each interpreter or compiler work in this way. So it's just not always going to work out. So the next kind of natural step here is like, okay, we can start moving things to the server side and start using Docker containers and then doing code execution in the cloud. Obviously, this is a lot more expensive and a lot more complicated to manage, but it's kind of worth it. You get a lot more freedom and a lot more power for the users. So the initial approach was create a single Docker image per language. You can keep a pool of Docker containers for each image around so that when somebody connects, they can just grab a pre-booted container and you can connect really quickly and start writing code. But you start running into some issues here. There's like tons of Docker images to manage and deploy. If we have 50, 60 different languages, it's a lot of management overhead. And then there's also like maybe a set of tools that we want available in every image, and making sure that every image has all the correct tools can kind of become a lot of work. You could maybe like have a base image and have them all show the same stuff, but then you can't use like the standard Node or Python Docker images. So you get into a mess pretty quickly. And then you have a problem where maybe somebody wants to use both Node.js and Python in the same project. Well, you have a Node image and a Python image, but you can't like just merge them together and use both of them. So the next iteration was this thing called Polygot, which was like, okay, instead of having a Docker image for every language, we'll just have one massive Docker image that has all of the languages. And it used like this crazy bash scripts and toml configuration files that would stitch together this massive Docker file that would install all the dependencies for all the languages that Replit supports. And this was an interesting idea, and it worked okay, but it had some like pretty big problems. First off, nothing was pinned, or not everything was pinned. Some things were, but like we're pulling things from apt and running, various scripts from the internet. And so every time you build this image, you have no idea like what you're going to end up with, and it would break frequently, and you just didn't know it was going to change every time you rebuild this image. The image is also really massive, so it took a really long time to sync anywhere. And then we also like had this problem of, okay, we installed Node in this image, but there's lots of different versions of Node, and we were stuck on like Node version 12, which is end of life now. So we were kind of in a weird spot. We're like, okay, we need to provide a newer version of Node, but we can't just upgrade it in the base image because that would update the base image for everybody's REPLs, and it would probably break a lot of REPLs that were relying on specific behaviors of Node version 12. So we didn't quite figure out how to like solve that problem. And then there's also this high barrier to adding new languages or tools for users. You have to come and learn our bespoke toml configuration format, open a PR, figure out how to test it and run this thing, and then convince an engineer to land the PR and ship a new version of Polygot. So notoriously, this is like a really slow and laborious process. So I did want to kind of show what it looks like. So this is Polygot. It's currently archived. We don't use it anymore, but here's all of the toml config files for all the different languages. And if you look at them, it's kind of crazy, the stuff that we were doing. So anyways, at some point, one of our colleagues was like, hey, this is kind of, all the tooling we built is kind of like Nix, but much worse. Like we had all these scripts that specify how you install the tools for a particular language, and then you can compose them all together, which is sounds kind of similar to what we saw with Nix. So we're like, okay, Nix looks obviously like way better than what we've been rolling ourselves here. So there were a couple of options that we could have taken. So we could have, kept with this idea of Polygot having this massive Docker image and just use Nix to build it. Like Nix is a great option for building Docker containers, it would have been pretty easy to pull together all the different languages that we want and build one Docker image for it. But the second one maybe solves some more problems, is a little more interesting, is we just install Nix inside the REPL and then let users use Nix to install the packages that they want. So after playing with the second approach, it was pretty clear that that was like the way to go. It was a really cool experience. So before I dive into like how we make all this work, I did want to give like a live demo. So I'll just create a blank REPL here. So let's see. So inside here, it's pretty empty REPL. You have like this README and nothing else. If you run, you see it just has like this cowsay thing. So if we actually look at how this REPL is configured, we can see that it has like this run command that runs cowsay, and we have this special replit.nix file. So let's say I wanted to write some Rust or something. We can see Rust C isn't installed. So all you do is go to replit.nix, go to add Rust C, and then if you just hit enter, it will just automatically detect that you've changed the file and reload the environment. So now if I do Rust C, you can see that Rust is now available in the environment. And this is pretty cool, but we also added some like special integrations here. So, maybe I want to write some JavaScript. I type node will automatically try to figure out, we notice that like node's not installed in this REPL. We'll try to figure out like where you might want to find that from Nix. And then we'll automatically add it to the replit.nix file. And now, you can write some JavaScript. Cool. And just for fun, you can start like Firefox or something. And we do some special stuff. We'll detect when you like open a window and automatically set up some VNC stuff and automatically show it in the workspace. So there you go. There's Firefox. So all of this is possible through Nix, and so it's a really cool experience. So yeah, let's get into kind of like how we made this actually work. So first off, before we get into how it works, there's some constraints that we need to know about that we have at Replit. For one, we have a very generous free tier. Like it's our goal to allow anyone to learn how to program. And so, making it so that you have to pay to use the product, like that's a really big barrier for a lot of users. So ultimately, we want to do our best to have a free tier. And so that means that we need to keep like the per REPL cost down. And so that can be done two different ways. Like we can share as much as possible between the REPLs. So if we have like some large fixed cost and we can divide it by all the REPLs that we run, that's great. And then we also need to restrict like CPU, memory, and storage usage per REPL. We also really want to keep the boot times really fast, on the order of like a few seconds. And as cool as Nix is, new users who are like brand new to programming shouldn't need to think about Nix when they're just getting started. So they should be able to just start learning how to program. That's kind of the whole point of Replit. So we need to make sure that we retain that. And so due to these constraints, REPLs do have a maximum file system of 1 GB. So in our first like prototype, we would just go take the Nix installation script, run it inside of our REPL, which worked if you use like single user installation mode, because it doesn't require any privileges or anything. And which was kind of cool. So you could use like NixM to go and install some packages. You can install cowsay or something small, and it worked well. But eventually you would just run into the disk quota if you installed anything that was larger than a gigabyte, or anything and all of its dependencies were larger than a gigabyte. So in reality, this meant that you couldn't really do anything that useful just having Nix installed. So we kind of had this naive idea. It's like, what if we just like pre-populate a Nix store with everything from Nix packages and then mount that in a REPL. So now when you try to go and use something from Nix packages, it's already in the Nix store. So essentially, this is kind of what that would look like. And this is very similar to what we run in production today. We have a shared persistent disk. This is like a Google Cloud terminology that is shared between all of our containers. And so this persistent disk is read-only, so we can attach it to as many virtual machines as we want. We mount that onto the virtual machine, and then we bind mount that the Nix cache into each REPL. And then we still want to have like a writable overlay on top of this, so we use like the overlay FS file system that the Linux kernel provides to give everyone a writable layer on top of the Nix store. One important caveat here is that the writable layer is on a scratch volume, and we throw it away every time your session expires. So this means that if you make any modifications to the Nix store, they're not persisted between session boots. So this is why this cache is so important to us. We need to make sure that most things that users are using are actually in the cache, so you don't have to download anything or touch the Nix store when the REPL starts. So you might be wondering, how do you populate a cache like this? So when I was first playing with this, I was just looking around at the various Nix tools and found this incantation with NixEnv where you can query all the available packages for your system and all the pre-built ones. So these are the ones that are available in the public binary store that Nix has. And so we can query all of those, do some rip-grep stuff to massage the output, filter some duplicates, and then use the Nix store realize command to go and install all of these into /nix/store. And then we can take that disk, make a read-only copy of it, and attach it to every REPL and mount it in. So it turns out that naive approach actually works fairly well. It's not without issues. I'll get into that a little bit later. But it creates this magical experience. This is how all REPLs are working today. So with the cache in place, you can now use NixEnv to install whatever you want. And it's kind of this magical experience. You can pick a really large package and it installs almost instantly because it's already available in the Nix store. But it still has that magical experience. But user experience still isn't optimal here. Users have to know about the Nix tooling to install packages. Any modifications to /nix are thrown away because we use that scratch volume. So even if you do install something, that's actually stored somewhere in the /nix directory. So next time you come to your REPL, those packages would be uninstalled. And in general, NixEnv and Nix profile are not really the Nix way. Instead, we want some way to specify the dependencies in some sort of a file or something. So this is where we created the idea of the replit.nix file. So before I go any further, I do want to go on a tangent here. I'm going to be talking about a thing called PID1. It's our init process, hence the name. So it's the entry point into the container for each REPL. And it just facilitates all of the IDE, the browser-side workspace stuff to the container interactions. So with that in mind, we needed a way to allow users to install Nix packages, and we needed to make sure that those packages were available when they ran their project or were using the shell. So we created this new file. It's really similar to shell.nix, and you might be wondering, why not just reuse the standard ones? But it's important to us that we control the interface here. So we could potentially include special integrations with Replit in the future, or if for some reason, shell.nix changed, I don't think it would. But it's just nice for us to be able to have an interface that we control. And then we also removed a lot of the standard boilerplate. So this is what a replit.nix file looks like. So you don't have to have the import Nix packages or the make shell or anything. So this just makes it a little less intimidating to users who are just getting into Nix. So internally, PID1 is going to use Nix shell, this replit.nix file, and a small Nix shim that creates a new environment based on, it's basically just taking the dependencies from the replit.nix file and passing it into that make shell function. And then it just runs a command inside that Nix shell to dump all the environment variables. And then we just save those somewhere. And then anytime we need to run the REPL or start the shell, we'll just include all those environment variables when we do a fork and exec. So, when you're in the shell, you just have all of those environment variables from the environment set properly. So, and that makes it, those things are now installed, I guess, in your environment. One thing that we did run into is invoking Nix shell at container startup was slow. It was adding multiple seconds to REPL start times. And that's not great. So there's two things we could do here. We could try to figure out what was slowing down Nix shell, and we looked into that a little bit, but we didn't find anything super obvious right away. So the next best option is to start caching things. So we wanted to cache the environment variable somewhere on the disk, and then we'd only reload the environment when we notice changes or something. So what we do is when we restore that environment, we just do like a quick check. We look for any Nix store paths in the environment, make sure that those are still present in the Nix store. And then we store some like timestamps on the files, like the replit.nix file and stuff. And so we can detect any time that those things change. And if needed, we can regenerate the environment. But most of our like prominent REPLs, we try to make sure that we're always hitting the cache so that we don't have to have this loading step anymore. So it's very fast. So there's a blog post about it if you want to read more. So this means that most REPLs like never invoke any Nix tooling. So as long as the cache is there and it's valid, we don't have to like run Nix or anything. And then we had this problem of we started rolling this out and users were like, hey, I was trying to use this tool that I could use before, and now it's not available anymore because Polygot came with like a ton of pre-installed tools in it. And so, maybe you try to run htop and it's like, oh, the command's not found. And now it's not really clear like what to do at this point if you didn't know about Nix or anything. And so we wanted to have a slightly better integration here. And so I had seen something called comma. It's a really cool project. Essentially, you can like prefix your command with a comma, and then it'll automatically find the binary from Nix, so you don't actually have to install the tool locally. So anyways, you took that similar idea and just hooked it up to the command not found like shell hook. And so it uses Nix locate and Nix index under the hood to automatically try to find that binary in the Nix store somewhere. And so now we have this experience where, if you have type htop and the command's not found, we can say we found it in Nix. We can ask you, we still want to have a confirmation step so we don't just start running random stuff. And so it'll ask you if you want to run it and add it to the replit.nix file. And more recently, we've utilized our Nix parser, which is just a Nix parser written in Rust. So we can make programmatic edits to replit.nix and automatically install these packages when we hit this case. So currently, all new REPLs are powered by Nix. So if you go to replit.com and you create a new REPL from the new REPL modal, it's going to be powered by Nix, whether you can tell or not. We currently have roughly like 8 terabytes worth of Nix packages pre-cached in that big persistent disk. And we currently offer like 2 snapshots of Nix packages. You can use 2111 or 2205. So we do plan to support new channels, but there's some interesting problems that we've run into. So I'll get into that here in a second. There's also a blog post that talks about powering all the new REPLs by Nix if you're interested in reading more. So let's get into some of the problems that we've seen. First off, there's kind of this distinction between language and system level dependencies. So Nix is really great for sourcing these system level dependencies, but it can also manage language level dependencies. And so this is great if you're like really buying into Nix and using Nix to build your package. It usually requires like using something to Nix tool, which will generate a bunch of Nix derivations based on your language dependencies, or by using some of the Nix packages helpers like Python 3.with packages or something. Unfortunately, like this doesn't really integrate well with the rest of our tooling. So we have like a nice packaging sidebar where you can install language packages, and we have a tool called Universal Package Manager, which is like a universal interface on top of like NPM, Yarn, Poetry, Cargo. And so this Nix stuff doesn't really integrate that well with those tools. And it also doesn't really integrate well with our caching solution either, especially like those 2 Nix tools are going to be generating lots of new derivations that are not in like upstream Nix packages. And so this means that we miss the cache a lot, which means we have to like download all these dependencies every time the container starts up, and you end up with like really slow boot times and start hitting disk quotas. And we also don't use Nix to actually build the user's project. We just use it to get the environment set up. We could maybe explore doing that, but ultimately our goal is to make it easy for users. So like if they're Googling and stuff, trying to figure out how to do something in Node, like we want to be using standard Node tooling instead of using Nix, so that they can find the resources that they find actually apply to what they're using. So one of the problems, though, is avoiding Nix for language dependencies has its own set of issues as well. In particular, Python is a real pain with this. So there's a lot of like Python packages that require native dependencies. they'll try to like load a shared object at runtime. And if that's not present on the system, it'll error out, and it's not a good time. You'll get a nasty error message in the shell. So currently, like the best solution we have here is by using LD library path to like add some extra libraries when we run the Python interpreter. So if you look at replit.nix inside a Python REPL, it looks something like this. And anytime like you're trying to use a native dependency and it's missing, you just have to know to go to the replit.nix file and like add it to this here. So it's really not great. We try to have a few pre-installed libraries that a lot of Python packages might use to make this easier, but it's still not a perfect solution. I do want to call out like something that's really cool and it's kind of new. It's called Riff from Determinate Systems. So I'm not affiliated with this project. I've not contributed to it or anything, but I think it's kind of straddling the same line here. The idea, my understanding of the tool is it handles a mapping of like language dependencies to system level dependencies. And so you can use Riff to install all of the native dependencies that you need to build or run your program. And you still use all of the traditional language tooling. So you're not having to completely buy into Nix and use Nix to actually build and run your project. So currently only Rust is supported at the moment, but it looks like more languages are planned. So I think this is really cool and it would be really helpful for us in the future. So it's something that we might look into integrating into Replit at some point. Another problem, as you may have guessed it, with the naive approach, caching all of Nix packages takes a fair amount of disk space. We found like a single revision of Nix packages takes like 500 gigabytes to a terabyte of disk space. And so once you start caching multiple channels and multiple versions of channels, like this adds up pretty quickly. And currently Google Cloud has a maximum persistent disk size of 64 terabytes, and the cost scales with the size. So things get pretty expensive. And then also, like most users are only using a tiny fraction of this. I think we ran some numbers, and I think it's something like 99% of users only use 6 gigabytes of this cache. And so there's definitely a lot of room for optimization and improvements here. So we have some ongoing ideas and projects to address this, but we don't have anything that we can share quite yet. Another issue that we found is all the users kind of share the same Nix channels. So since all the users share the /Nix from the persistent disk, like their Nix profiles and Nix channels are all set up the same initially. And so currently we have like a Nix channel per Nix stable release, but the revision of each channel is shared amongst all the users. So unfortunately, we found out that we can't just keep updating, even on a stable channel, we can't just keep updating these channels because sometimes things break. So an example of this is we tried to update 21.11 at one point, and at some point the Swift package stopped building for some unknown reason, and the deploys continued on. And so we updated Nix packages and then found out a couple of days later that all Swift REPLs stopped working at some point. So ultimately, this means like long-term, we need a way for each REPL to pin to a specific revision of Nix packages. That way, we can still update non-Swift REPLs and leave Swift REPLs pinned to a version of Nix packages that actually works. And another problem that we've run into is like maintaining all of these language configurations. So for some context, before we switched to Nix, we maintained a JSON configuration file for each language. It included stuff like how to run the project, how to start the language server, how to run the debugger. And one major drawback of this approach is users had really limited ability in overriding any of these settings. So especially as we're adding in Nix, like not having support to change these settings really limits Nix's usefulness and effectiveness if you can't just go and like change the run command to run something from Nix. So ultimately, we decided we needed to expose all of this configuration via a special file called the .replit file. And here you can set up like how to run the REPL, how to start the language server, how to do the debugger, and anything else that you can configure. You can now do it as a user. And we create this concept of template REPLs, which are REPLs that have a base.replit file and a replit.nix config. So use both of those. And then now if you start like a Python project, you're starting with like a baseline set of configuration that actually works for that. One of the problems, though, is users can make arbitrary modifications to these files, which is, in a sense, is kind of nice. Users have a lot of freedom in what they can do. But if we make changes or updates and improve these configurations, it becomes kind of difficult to apply those changes to pre-existing REPLs. If they haven't touched these files, it's not a big deal. But somebody could have completely rewritten their replit.nix file, and now it's unclear how to actually apply that change. So again, we don't have like a amazing solution for this quite yet. We have some ideas that we're working on, but nothing that we can share quite yet. And here's like what a .replit file looks like. You can see you can pick the Nix channel. You can specify how to run the project, how to start the language server and stuff. Yeah, so I also want to talk about like how we use Nix internally. So that's kind of the Nix stuff on the product side. So unfortunately, like Nix internally isn't super widespread among our developers yet. However, there's still a few of us on the team that use it daily. We've added a shell.nix to most of our repos, so you can quickly get started and have the tools that you need to develop. One interesting thing I did want to call out that we use is we use Nix to build and deploy our PID1 bundle, as we call it. So that's just PID1 and all of its runtime dependencies. So we use Nix to build the binary itself. We use one of the Nix wrappers or helpers called wrap program to set some environment variables before PID1 is executed. So this includes like adding stuff to the path. So we can have any expected binaries are always available to PID1 regardless of the Docker image it's in. And then what we'll do is we'll export the closure of PID1 to a compressed tarball. And so, like I said, it consists of PID1, all its runtime dependencies. Our container manager VMs will pull the tarball and then bind mount that into the container and then set the entry point to PID1 inside that Nix store. And so this decouples PID1 from the actual Docker image, which for the most part, like most use cases with Docker images, doesn't make sense. But for our case where PID1 is separate from like the Docker image because the Docker image is more about like the development environment that we give to the users, it makes a lot of sense to have this separation. And we can always ensure that tools like Silver Searcher or UPM and prybar, which are some binaries that we have internally, that those are always available regardless of where PID1 is at. So this is really useful when we still have some like legacy Docker images. And so we can keep updating PID1 and adding stuff here, and we don't have to worry about updating those legacy Docker images to make sure that they include all the things that we need. So with this process, we just kind of forget that we're using Docker images under the hood. We don't have to touch them very often. So that's very nice. So yeah, so that's kind of a brief overview of like how we use Nix at Replit. There's definitely still some rough edges, both with the Nix tooling and with how we use it. But we definitely think that Nix has a bright future in software development and solves a lot of really, really important problems, both in software development and deployment. And I do want to plug, like, if any of these problems sound interesting to you, like, let us know. We're hiring, just replit.com/careers, and we'd totally love to have more engineers with Nix experience. I also put some links here that to some of our blog posts that talk about some of our Nix stuff as well. So that's all I got. Happy to answer any questions.
Thanks. All right, Connor, thanks a lot. That was awesome. We got a few questions. I think you might have answered some already, but let's just field some. So one question that came up, you talked a bit about handling pinning of channels and inputs. I don't know if you want to elaborate on the question specifically was, is there any special handling for pinning of channels and inputs? I think you might cover that.
So currently we just use like the standard Nix channel tooling, and then we set the channel to a specific like revision of Nix packages. So we're just pinning it at that level. And since our persistent disk, it caches all of Nix and not just Nix store. Basically, when we're building that persistent disk, we pin the channels with Nix channel on that disk, and then everybody inherits that. So we don't do anything super special there. We would be interested in maybe looking at flakes. It seems like that's kind of the direction everything's going. So it'd be cool to integrate that, but I don't have any, I haven't played with that quite yet.
Yeah, that makes sense. Another question that came up from Akenji was, did you think about not using .nix file for replit.nix, something like devshell? And if yes, what were some pros and cons you thought of?
So not using, having .replit or?
Yeah, not having replit.nix, something like devshell. I think this might be a Flake thing that I'm not
okay.
either.
Yeah, I'm not super familiar. I will say, I don't know if this is quite the question, but we did play with the idea of moving all the REPL config, so like the .replit config, into like the replit.nix file, which would be kind of cool. We just already had the .replit file for some like very basic config, so it made more sense at the time. But in general, as the ecosystem kind of settles down on like the new Flake stuff, I think we'll probably head that direction and try to stay pretty standard. But at the same time, we still want to have room for like special integration with Replit itself.
Word. Yeah, another question from Akenji, which is a good kind of point of departure for conversation, was what is the functionality of Nix itself that doesn't exist yet, but could help you in some of your goals?
Yeah, so I think one thing that would be really interesting is this idea of like Nix union stores. I think there's a GitHub issue about this. But it'd be really cool if each user could have their own like private Nix store that maybe they could share among all their REPLs. And then we have our public cache that's like has all of the like pre-cached stuff. And you could merge these together. And so, users can cache stuff in their own Nix store that might be private to them, like it might have their own source code or secrets or something. And it separates it from the public cache that everyone else shares. So I think that would be something that's really cool that doesn't quite exist yet.
Yeah, I've thought about that before too, like doing sub caches that you can have private caches for your own community or your own project or whatever. Yeah, I'll have to check out that issue. Another question from Awesome Ride that came out was, how much disk space is saved by using a Nix store optimization? Did you try using deduplication and compression at the file system level?
That's a good question. I feel like I tried to do like the hard link optimization at some point. I don't have the numbers off the top of my head. It's probably been a while since we ran that, so it would probably help out a lot. I also know that I think like content addressable Nix would probably help here. There's probably a lot of like packages that are actually the same but have a different address or something. So there's probably some optimizations that we could do there.
Word. Yeah, I think there is some ongoing work on content addressable Nix. I haven't followed it too closely though. So Connor's slides are a REPL on Replit. I'll share these in the chat here if you can use them. And
yeah, just to prove that, here's the REPL where I made all the slides.
Nice. Yeah, very cool. I think you might have like silenced everyone with all your questions. You've answered all the questions before they even occurred. Anything else that we can talk about regarding kind of what you see, like what you would like to see from Nix as a community, or problems that you would like to see solved outside of Replit?
Yeah, I think like this is like the ongoing one, and just Nix in general. It's just like how do you teach people how to use Nix? How do you make Nix easier for users? We've gone through some links to kind of hide it a little bit from like very new users because we don't want to overwhelm them, but we don't want to keep it too far out of reach that like advanced users can't start using it. But like it's a paradigm shift, and it's a new language you have to learn. It's a new model you have to learn. So we're always thinking about like how we can make it easier for people to jump in and learn how it all works. So I don't know the answer there, and I know there's a lot of work going on in the Nix community to make it easier to learn how to use Nix and onboard. But I think that's like one of the biggest problems to solve for Nix.
Yeah, I think like what you showed about kind of just taking out some of the boilerplate and making it so that you can expose this replit.nix file that users can actually edit, and having the shell hook that will automatically add packages into it is super elegant. I actually hadn't realized that you guys did that. And yeah, it's not necessarily there's a conceptual gap to fill, but there's also this like user experience gap to fill between this, like, this isn't just for graybeards and like Nix, black belts. And we can also have people that are walking into programming and be able to manage a Nix shell without having to have a PhD in it,
Yeah. And I think it's hard to sell it to people who are new because like they haven't run into a lot of the problems with traditional package management, right? It's like with traditional one, you just run a command and you have the thing installed. Like how can it be any simpler than that? But then, after you do it for a while, you end up, dealing with all sorts of weird things, or it works slightly different on someone else's machine and stuff. So Nix solves a lot of these problems, but it's hard to sell it to people who haven't experienced those problems yet. And it's a lot more complicated to get started. So
yeah, it's almost like you have to get them, like, take away the cost of like the middle of the learning curve. For like as beginner programmers, yeah, you just like pip install whatever and it works fine. But a year into programming and you start dealing with all this other complexity that has accumulated through your entire learning experience, and you're wondering how to solve it. And like the way I look at it is like buying into Nix or finding a path for learners to use Nix, like, takes away that cost and that time lost in the 6 months, a year, 2 years down the road for them. And so that's a major win.
Yeah, for sure.
Not an obvious one, I'll give you that.
And my favorite is the GitHub READMEs that have like the 500 commands to install the 500 dependencies. Those can finally go away once we're all on Nix. But
right, exactly. Cool. Well, I don't see any other questions coming in, so I'm happy to leave it here. This was an awesome walkthrough of what you guys have done. Super excited to see where Replit goes from here. And this lecture is recorded, so we'll have it on the NixOS Foundation YouTube channel. And yeah, Connor, any parting thoughts?
No, just thanks so much for the opportunity. I think we have some exciting stuff coming up, so stay tuned.
You guys have exciting stuff coming out every week.
It's true.
Yeah. Well, thanks a million, Connor. I really appreciate you doing this, and
Right.
see you around.
All right. Thank you. See ya.
Ciao.